So I'm continuing my discussion of discrete random variables, and here I have a probability distribution for a random variable x. X can take on a value from 0 to 12, and here's the probability that x would take on any one of those values. So for instance, there's a 0.15%, a 15% chance that x takes on a value of 3. Now, what's the context here? These values of x are the number of people in line during the lunch hour or at lunchtime at a fast food restaurant. So let's see what we can do with this information. So first I'm going to put this into my calculator as a list. So I'm going to clear what I have in here for now. And add the values in list 1 for the values of my random variable 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. And the probabilities are 0.011, 0.035, 0.089, 0.15, 0.186, 0.172, 0.132, 0.098, 0.063, 0.035, 0.019, 0.004, and 0.006. So first, let's check to make sure that this is a valid probability distribution. So remember, for that I need to check that each of these probabilities is between 0 and 1. So I'm good to go there. But I also want to make sure that the sum of my probabilities exactly equals 1. So for that, I'm going to go to my list options, over to math, and choose option 5, and sum list 2. And sure enough, those do sum to 1, so I can confirm that this equals exactly 1. So this is a valid probability distribution. So next, let's calculate the mean for the random variable. So for that, I'll go to my stat edit menu, and in list 3, I'm going to take L1 times L2, and now I want to sum the values in L3. So I'll quit this, go to my list menu, over to math, and choose list 3. So these sum to 4.87. Now what does that mean? If you were to randomly walk into this restaurant at lunchtime, you're never going to see exactly 4.87 people. You could either see 4 or 5, but so this isn't what we expect to see anytime we walk in. But if we were to visit this restaurant many times randomly at lunch and note how many people were in line, and then take an average long-term, that long-term average we expect to be 4.87. So remember, this could also be called the expected value of x is 4.87. So that's the long-term mean value for the random variable. Okay, next let's get an idea of the typical deviation from the mean. In other words, the standard deviation for the random variable x. So I'll go back to my calculator. Under the stat menu, I need to add another column. This is list 4, where I take list 1 values, multiply them by themselves, before I multiply them by the probabilities in list 2. Once again, I want to total this column, so I'm going to leave here, go to the list menu, under the math options, number 5, and this time I want to total list 4. So the total for list 4 is 28.686. And remember that I want to subtract from that the square of the mean. So minus 4.87 squared. And that gives me 4.9691. So I'm not finished. I need to take the square root of that result. And I get that this is we'll say 2.3. I'll just round it 2 decimal places. So the typical deviation from this mean is a little more than 2 people. So you might want to say that the average is around 5 people in line, but the typical deviation from that mean is around 2 people. Okay, a few more things that we can do with this. What if you wanted to know that the probability that when you walk in, you'd find exactly 8 people in line? So the notation I'll use is this is the probability that my random variable takes on the value of 8. So I can look straight into the table here and know that that's 0.063. What if I wanted to know the probability that I would walk in and find at least 10 people? So that would be the probability that x would take on a value of 10 or more. So for that, I need to consider these 3 possibilities together. So I'm creating an event that combines 10, 11, and 12. Those are disjoint events, so I can actually just add 0.019, 0.004, and 0.006. 0.019, 0.004, 0.006, and that's 0.029. So there's about a 3% chance that I would have 10 or more people in line. Now, what if I wanted to know the probability that I would have at least 1 person in line? So in this case, I'm looking at any one of these things could happen. I could have 1 person, 2, 3. Now, we have an easy way to do it and a hard way. The hard way would be to add all these probabilities together. But the easy thing to do here is to say that that's 1 minus the probability that I'd have 0 people in line. So I'm using the complement rule here. So that's 1 minus 0.011. So 1 minus 0.011, and that's 0.989. So there's almost a 99% chance that I'm going to find somebody in line if I randomly drop in at lunchtime. Okay, I'm going to stop for now, and in the next video I'll have one more example that has to do with insurance.